NASA set to launch probe on asteroid mission. Scientists call it a tag, high five or kiss. It's the critical moment 4 years from now when a NASA probe, scheduled to launch from Cape Canaveral before sunset Thursday, is expected to stretch out a robotic arm and gently touch the primitive asteroid Bennu. If the 5-second contact goes as planned, the arm will suck up at least 2 ounces of loose gravel and dust from the space rock's surface, then store it in a small capsule slated to drop back down to the Utah desert in 2023. The pristine material, to be the largest sample returned from space since the Apollo moon landings, may hold water ice and organic molecules like those thought to have helped seed life on Earth, and perhaps elsewhere. We're going to an asteroid that represents the first building blocks of the planets in our solar system, said Dante Lauretta, lead scientist from the University of Arizona for the $800 million mission named OSIRIS-REx. We believe these hold precious organic molecules that were the precursors to life on the planet. The mission's name is an acronym for Origins, Spectral Interpretation, Resource Identification and Security Regolith Explorer. It is NASA's first attempt to collect and bring back an asteroid sample, following a Japanese mission's 2010 return of grains from the asteroid Itokawa. A 189-foot United Launch Alliance Atlas V rocket is scheduled to lift off with the NASA probe from Cape Canaveral Air Force Station at 7:05 p.m. ET Thursday. There's an 80% chance of favorable weather during a nearly 2-hour window at Launch Complex 41, which was undamaged by a SpaceX rocket's nearby explosion a week ago. Once safely in space, the spacecraft the size of a small SUV, built by Lockheed Martin, will take 2 years to journey more than 5 million miles and meet up with the asteroid that Lauretta described as a small mountain in outer space, measuring about 1,600 feet across. From thousands of candidates, Bennu emerged as NASA's ideal target. The asteroid's orbit around the Sun is close enough to reach. It doesn't rotate too quickly. And telescope observations show it is carbon-rich, more likely to hold amino acids or other organic compounds left over from the solar system's formation more than 4.5 billion years ago. Those factors make it one of the most fascinating and accessible asteroids, said Christina Ricci, the mission's deputy program scientist at NASA headquarters. Over 2 years, a suite of cameras and sensors will create high-resolution, 3D maps of Bennu's surface and composition. We will be able to see an object the size of a penny, said Daniela Della Justina, lead image processing scientist at the University of Arizona in Tucson. Scientists will know more about Bennu than we know any other near-Earth asteroid. That knowledge will include the first close-up study of how heat from sunlight gives asteroids like Bennu a slight push, changing their trajectories over time.